Welcome to our video here on 1.3 rates of change in linear and quadratic functions. It's going to build off of our average rate of change that we just did last time. So let's start off here. Oh, before I do that, don't forget to like and subscribe. All right, so we're going to start off with average rate of change of a function, which is the same thing as the slope of a secant line. And this is what we talked about last time. This is just in function notation, but you need to know this. Super important for you. Slope of the secant line is just f of b minus f of a all over b minus a, which is just the slope of a line. The secant line is, by the way, for those who don't know, if I just draw any type of graph and I want to find the average from this point to that point, if I connect those lines, this provides me a secant line. So this is the secant line right here, this dotted line. That is the secant line. Okay, just an example. I'll erase that. Okay. All right, so here we go. Let's just find the slope of the secant line from the point -1, 4 to the point 1, 2. So I'm going to quickly label this for you. We have the point 1, -2, which is right down here. And we have the point -1, 4 right up here. And we're trying to find the slope of that secant line. So all we're going to do here is, by the way, it's the same thing as y2 minus y1 over x2 minus x1. And since this is a coordinate point, it's probably easier to use this one rather than the f of b minus f of a, because we're not given a function, but rather we're given an actual coordinate points. All right, so what is this going to do here? Well, I'm going to choose y2 to be my larger x value. So I'm going to use this as x2, y2, and this will be up here, x1, y1. So I'm going to get -2 minus 4 all over 1 minus -1. It's going to give me, on the top, I'm going to get -6 over 2, which is the same thing as -3. So this is going to be the slope of my secant line. So the slope of this dotted line I just drew earlier is -3, which is also known as the average rate of change. All right. Okay, we got a example down here for a function. This gives us a function now. Find the slope of the secant from the point -1 f of -1 to the point 1 f of 1. This is just a really fancy way to just ask for the x values and y values. So real quick, let's find the y values. So right here, these are just y values. Okay, so we'll call this y1, we'll call this y2. Okay, well, we know that f of -1 is going to equal, if I plug everything in, -1 plus 2 times -1 minus 4. That's going to give me an answer of, what, 1 times -5, which is -5. So this is the same thing as the point -1 comma -5. And then f of 1 is going to be 1 plus 2 and 1 minus 4, which is going to give me 3 times -3, which is -9. So this is going to give me the point 1 comma -9. So to find the slope of the secant, we'll just do our coordinate point one up here again. So I'm going to get -9 minus -5 all over 1 minus -1, which is going to be -4 over 2, it looks like. So this answer is going to be -2. So that is our slope of our secant line, -2. Okay, let's talk about average rate of change using tables. So I'll just do the problem. It's a little bit easier to explain. So right here, example 1, we have a table of output values and input values right here. So we have this table. What I'm actually going to do is I'm going to try to find the rate of change from, oh, that is not what I wanted. The rate of change from here to here, from 5 to 3. That change is going to be a -2 because it's going down 2. The change from 3 to 1 is going to go down 2. Change from 1 to -1 is going to go down 2. And another down 2. So what's the average rate of change of that? Well, this is the delta y part. And it looks like our delta x is consistent. Our delta x, we're just changing this by 1. These are all changing by 1s. Okay, those are going up by 1 every time. So average rate of change is going to be -2 over 1. So this average rate of change is -2. This average rate of change is going to be -2. -2 and -2. So don't forget our average rate of change is also delta y over delta x, which is what we talked about in one of our previous videos. So the average rate of change, this is the part that's up here now in this box. So let me just explain now the average rate of change of linear functions is the average rate of change of the change would be 0. So if I'm looking at these numbers right here, that has no change. So the average rate of change is going to be 0. So what is the change of the average rate of change? 0. All linear functions I'll put apostrophe functions average rate of change changes at a rate of 0. So we're finding the average rate of change here. This is the average rate of change, but then we need to find the change of the average rate of change. Okay, let's talk about the average rate of change of quadratic functions. So linear, the change of the change is 0. Quadratic functions, a little bit different. So if I'm looking at this table of values right here, looks like I'm going up 10, up 4. Those are plus signs, by the way, if you can't read that. Up 2. And, no, I lied. That's not up 2. Let's try again. I don't have students to correct me in my videos. This is going down 2, and this one's going down 8. This is my change in y. My change in x every single time is going to be 1. So my change in y over change of x is going to be here. We got 10, 4, -2, and -8. Okay, so now let's look at the change of the change. So now let's go here. How do we get from 10 to 4? Went down 6. How do we go from 4 to -2? Went down 6 again. How do we go from -2 to -8? Went down 6 again. So I'm telling you that this is a quadratic function. So what is the average rate of change of this change? This is equal to -6. So down here, this question, are the average rate of change increasing or decreasing? What does that tell you about the concavity? So the average rates of change are going down, right? So for this one, we are decreasing because we are negative. Okay, so the average rate of change is decreasing. Average rate of change is decreasing, so that means that we are concave down. So which means that this is a quadratic. Quadratic's going to look something like this. Okay. So concave up, just to remind you, it's right up here in this chart right here. That's when the average rate of change is increasing, and concave down is when the average rate of change is decreasing. So, the average rate of change is negative for concave down. So concave down like a frown, concave up like a cup. A little bit of review right there. Okay. A table of output values, a function is given for equal input values. Find the average rate of change over the intervals, and then we'll answer these other parts here in a second. So if we notice here for our change in y, looks like I'm going down 24. Looks like I'm going down 8 here. Looks like I'm going up 8, and then it looks like I'm going up 24. And then our change in x is going to go up 2, up 2, up 2, up 2. So my average rate of change is going to be negative 24 over 2, which is negative 12. We're going to have negative 8 over 2, which is negative 4. We're going to have 8 over 2, which is 4. And then we're going to have 24 over 2, which is 12. So this is the average rate of change. Part A. What do you notice about the change in the average changes? Let's look at that. Looks like I'm going up 8, up 8, up 8. So what do you notice about the change in the average change rate? What do you notice about the change? It's a lot of changes. What do you notice about the change of the average rate of change? Well, they are all increasing by 8. So our average rate of change is increasing or decreasing. So I said they're all increasing by 8. What did I tell you about the concavity of the quadratic? So this is going to be concave up because we're positive. Up like a cup. All right, and that's going to wrap up this video.